virtual Embryology Virtual Lounge. So today's topic is going to be about sperm cryopreservation. Before we started, I'm just again warmly welcome you come to join this session, and this is Bingu, the technical application manager in charge of Asian Pacific. And the aim of this kind of session is to provide a platform for the embryologists to stop and think, to learn from, to review the techniques, and to think deeply for the to improve the whole technology. And the whole session will be recorded, just in case if anyone who want to join but don't have the time to join. So we will provide a replay afterwards. And during the whole session, all participants will be muted, just to guarantee a perfect session. And at the last minutes of this session, we will give you time to express your point of view on the topic and also to ask the questions. So the session is going to be started on 3 p.m. sharp. There's still 3 minutes remaining. We will wait a little while just in case any other participants want to come to join this session. Okay. So again, just warmly welcome everybody who have joined to this this virtual launch of clinical embryology. Today's topic is about sperm cryopreservation. This is Bingu, the technical application manager in charge of Asian Pacific. We want, as Fujifilm Around Scientific, we want to provide a platform for everybody to stay for a while, to review, to think, to learn about the technique. So before we start today's session, I want everybody who has already been in this room to mute yourself so that we won't, we can guarantee the best effect of this session. And yeah, I still can hear someone is host. So our host will probably mute you, and we will unmute you at the end of the session, so that you can express your point of view on the topic, or you can ask the question. Well, we will begin on today's session. So as I said, today's session is about sperm cryopreservation as just part of the artificial of the technique. So it is interesting to know that the attempts for sperm freezing was back to more than 200 years ago by the Italian doctor Lorenzo Spallanzani. The first human live birth using frozen sperm was reported in 1953 following short-term storage of sperm in dry ice solid carbon dioxide. Um, and then by 1963, liquid nitrogen was introduced as a method of long-term sperm cryopreservation, which allows sperm freezing to become widespread in healthcare. And despite the usefulness of it, cryopreservation may lead to deleterious changes of sperm structure and function. So there's certain indication for this technique to be techniques. So sperm cryopreservation is facilitating the fertility management for certain cases. So on this slide, you will see the list of indications. So first of all, surgical sperm freezing to prevent the need to repeat the surgical procedure. And also ejaculatory and erectile dysfunction is also another indication, one of the indications for sperm cryopreservation. The risk of potential, I assume, will be also the impaired semen parameters would also be one of the indications for that. And it is also one of the ways to preserve the productivity, reproductive ability for those patients with oncology treatment, and also for those ones for fertility management. It is a very useful way for donor sperm. So it is necessary and must to cryopreserve the sperm for sperm donation. For some patients with chronic diseases, yeah, they will have the need to freeze their sperm. And for ART treatment, especially for IVF treatments, if on the day of egg retrieval, the male partner is unavailable on that day, they will be request to have the cryopreservation of sperm. And also for some professionals and for some occupations, men who are at risk to be exposed to hazard materials, toxicants, or radiation due to their job, they will have the need to cryopreserve their sperm. For freezing, so normally for the sperm cryopreservation, it includes the two parts, both freezing and thawing. So for freezing, normally we have globally we have four kinds of way to do it. So traditionally, I think it's the most old school way. It's the slow freezing. So it will take 2 or 3 steps described from 3 steps to freeze the sperm. So normally it will be after the mixed with cryopreservation media, and the sample will be stored from the room temperature to 5 Celsius degree, and then the temperature will decrease on the pace of 0.5 or 1 degree per minute, and then it will drop from 5 degrees to 80 degree minus at a rate of 1 to 10 degrees per minute. And then will plunge the placing specimen at a different distance from liquid nitrogen vapor. And that is the manual way of doing it. And then normally, for others, we have the programming machine to which help it the whole procedure to be automatically done. And then recently, I think for most of labs, they're using the more easier and rapid way. So it will be after the pre-equipment of the cryoprotectant media. We will the lab staff will put it directly contact with the vapor for 15 to 30 minutes, and then dip it in directly into liquid nitrogen. Recently, for some labs, for some researchers, they're trying to do the vitrification. Vitrification of sperm. It's more or less the same way of oocyte vitrification or embryo vitrification. Just use very little volume of media and sample, and just dip it directly into liquid nitrogen, so that is down. But the consequence or outcome for this method is controversial. Something it does okay for the sperm. Another thing, sperm is quite different from oocytes or embryos. The outcome is not that ideal. And also in some regions, like in China and some places, they're now more focused on the small numbers of small mitosia. So for the very little count of sperm sample, they will do some ways to preserve them, like using the 5 microliter drops to freeze the sperm, which was captured by ex nihilo under the scope, and then just dip it directly into the vapor, and then directly dip into liquid nitrogen, so that it can be used right after it was thawed for ICSI. And for the thawing part, normally you need to allow the cell to recover its normal biological activity, trying to avoid abrupt thermal and osmotic changes. And also you need to think about, during the cell rehydration together with the appropriate removal of cryoprotectants. So there's mainly 3 ways of thawing. So I listed here. The first one is thawing at room temperature for 10 minutes, and then subsequently thermostat pass at 37 degrees for another 10 minutes. Or you can do it like thawing in the thermostat and water bath at 37 degrees for 10 minutes. And the last one would be thawing at room temperature for 15 minutes. But none of these 3 methods are used for warm vitrified samples. So I put the paper I referred for thawing procedures. So if anybody who was interested in that, you can just go and check it out. Before the methods, we will go to think about the dynamics during freezing. So the main characteristic of sperm cell that is it is small cell with large surface area, which makes it less susceptible to damage. However, during freezing, cellular and molecular changes have adverse effect on sperm function. So normally it probably will go through thermal shock while the temperature drops, and also the membrane fluid will change to gel, and changes in arrangement of phospholipid molecules which will lead to the increase of permeability. With the continuous temperature drop and rehydration, gel phase changes and extracellular fluid froze. The permeability continued to decrease to the point of membrane no longer permeable, and any fluid remaining in the cell might cause ice crystal formation, which will cause severe damage to the cell. And also the osmotic and toxic damage during hydration due to extracellular high concentration solute will be severe. The scientists also have observed calcium influx towards the cell. So calcium balance is important post-thaw for good recoveries. So that is also very important. It will so the previous mentioned event during cryopreservation process for both freezing and thawing will contribute to sperm cell damage, such as alternation of cell membrane structure. So normally it will include the protein degradation and phosphorylation, and it will also cause achromosome disintegration, and which will lead to capacitation-like changes. Sometimes it might damage the mitochondrial, which will affect the sperm mobility and the viability after thaw. Due to ROS production and lower antioxidant enzyme activity, sometimes it will lead to the damage of DNA and genetic materials. So the DNA damage will happen to both either the single or double strands. And these functional and structural change will cause the impaired motility and kinetics. It's this impact on post-thaw sperm. So it will be like related to decreased normal forms due to the osmotic changes and decreased survival rates. It will also lead to decrease the ability to fertilization, and it will cause the just mentioned achromosome changes, DNA damage, and which finally will lead to impaired embryo development. So as for all the points mentioned, people are always thinking where it can be approved. So when thinking about this part, we really need to dig it up about the components in the media, in the sperm freezing media. So let's just see what is in the sperm freezing media. So first of all, which is also the most important thing, is the cryoprotectant. So the cryoprotectant is divided into two categories. One category is the permeable cryoprotectant. It will pass through sperm cell membrane, which will enable the displacement of water in the cell. So the examples of this category will include glycerol, DMSO, and ethylene glycerol. And the other category is the non-permeable cryoprotectant. It will promote the cell dehydration by means of a osmotic imbalance. So normally those will include the glucose, sucrose, trehalose, and raffinose. So the main function of cryoprotectant, no matter permeable or non-permeable, they always help to decrease the freezing point. It will help to decrease the ice formation within the spermatozoa. and it will help to stabilize the lipid bilayer and protein. Finally, it will reduce the osmotic shock. Besides the cryoprotectant, it will also include the buffer, which help to maintain the pH. So the buffer normally will include like the tris or the hippies, which will normally in the handle media and also the test. So just like in our product, the Arctic sperm cryopreservation media, we have the dew buffer system in that, which is both hippies and MOPS. It can cover a larger temperature from room temperature to 37 degrees. And also, it will the media will include antioxidants. The antioxidant will be divided into also two categories. One is enzymatic. Sometimes it will it will mostly include the GPX and SOD. And the other category is non-enzymatic. I will like include the example of these category will be like vitamin C, vitamin C, glutathiones, and hypertarium. So the main function of this component is mainly to neutralize the endogenous RS, the oxidative stress, and also they're also the radical scavengers. And for others, sometimes it will have the EDTA or citrate as calcium chelators in the media, and also egg yolk, albumin, or lactin, which provide the cell membrane establishing molecules. So just as another product from Around Scientific, the TYB sperm freezing media, it is most reputed in the sperm freezing media category, and with co-function with the sperm plasma, it will help to preserve the sperm motility post-thaw. And for sperm cryopreservation, we always want to take these points into consideration. So first of all, the cooling rate and thawing rate. I think it's more or less the same like for the cryopreservation of gametes and zygotes. So the main point is to avoid ice crystal formation, which will cause severe damage to the cell. So, and also we need to think about the progressive addition of cryo media and equipation time. The rate of adding the cryoprotectant to the sample and proper equipation is affecting post-thaw results. Parameters and kind of sample before freeze is also correlated to the post-thaw parameters. And we can never neglect the sperm's sample cryo tolerance. So even for the same patient, for the same donor, for the different sperm samples will have the different tolerance. So it can never be ignored. And ROS generation is also a very important factor to think, to consider. So it will cause the DNA damage, and which will lead to poor embryo development. So we're still working very hardly in this field to develop to find more future post-thaw biomarkers to indicate successes of the process. So it is the future studies to take molecular markers for cryoprocess is needed. And this is all for today's topic about sperm cryopreservation. And now you're welcome to talk to express your opinions about this techniques, and also if you have any questions, you can have the time to express to raise the questions either on the chat board or can unmute yourself and speak. Any questions? I know it is very, it's not that deep research, is mainly the basic idea or knowledge about this techniques. So again, we want to, as Fujifilm Advantive and the media company, we want to just pick up one procedure, one point from this field, from this technique to help review the every protocol to help to think. You tell the vitrification. Okay, so there's one people asking about the vitrification of sperm. So normal now I've heard something about vitrification of sperm is more or less like the same like the vitrification of oocyte and embryos. So normally they will just process the sperm to pre-wash the sperm and then mix it with the sperm freezing media, and then they will load a very little volume like 5 microliters or something onto the vitrification device or something like that. So and then they will directly dip it into the liquid nitrogen, and so the temperature will drop severely and rapidly, and then they will just close it and put it into liquid nitrogen for storage. The procedure is more or less the same as vitrification for embryos. They just use very small volume drops which would have sperm in it. So for the sewing of that part, normally it's just like also the same, or like to prepare some sewing the sewing drops, which will be preheated to 37 degrees, or some labs they will just use the preheated oil dish. So they will just take the device out, uncap it, and dip it into the warm media or warm oil, so to see it thawing and floating down from the device, and they will just move on to the direct the following procedure. Good outcome from manual slow freezing. What is the procedure to obtain good outcome from manual slow freezing of sperm? Okay, so I think it's all about the details about how to freeze. So just as I mentioned, so when doing the, first of all, it's always the to pay attention the parameters of sperm samples before freezing. So if the parameter is not good, so you can never expect it will be okay. It will be better before that. So so that is the point need to consider. And also when you adding when you look at the product insert protocol provided by all the commercial media on the market, you will see we always say just to job wisely adding the freezing media and mix it with the sperm sample thoroughly and gently, and until the final volume has been added. And also you need to give time for the sample to have to equivalent with the cryoprotectant. So it will take like at least 10 minutes or 5 to 10 minutes for the samples to equivalent with the freezing media. So it will help to promote cryoprotectant to get into the cell and to dehydration the cells. And after that, I remember when I take some workshop for the sperm freezing, the trainer they always say so one expert always say don't use a very large volume for each vial. So he mentioned in his lab he always keep it very low, less than half a microliter. So that's 0.5 microliter. And then it will, after the fully equilibration with cryopreservation media, just put it into the liquid vapor, which is like 10 or 20 centimeters above the liquid nitrogen for 10 to half an hour. And then you can just dip it into liquid nitrogen for storage. And that's the whole point of that. And also, I remember when I discussed the same procedure with the lab director in Taiwan, she shared her experience of cryopreservation. She said she always told his colleagues and also the other embryologists that while doing sperm preservation, no matter what sample it is, do not pre-wash the sperm. So in her point of view, the sperm, the semen plasma, it helps to protect sperm, especially while using the TYB media. So the egg yolk together with the semen plasma, it will help to protect sperm survival rate also. So that's some of the experience shared by the other labs which have a good experience of sperm cryopreservation. Any other questions or any other experience you want to share with all the embryologists here in the Zoom? So the raw semen sample, yes. And sometimes the semen sample is, the volume is really high, so they will, yes, to save the volume and sperm media, the sperm freezing media it will, the option way is to centrifuge the sample and just to discard part of the plasma. And then still you will remain some of the semen plasma there because it will protect the sperm innets. And also, so if for that those big how long to spin the sample? I think it varies depending on each lab's protocol. So in my lab, when I was still in the lab, we normally will like spin the sperm sample for like 5 minutes to 10 minutes with 200 or 300 G. How do you process in situation where sperm parameter are deficiency? Well, first of all, still I want to emphasize, and everyone will tell you if the sperm parameter before freezing is deficient, is low. So you can never expect it will be the outcome will be good. So mostly it will be even bad, especially you will find from my experience and for those kind of sample, the tolerance for freezing is really poor. So you cannot expect it will come out good. And for those parts, yeah, so I did use not allocated into different vials with very small volumes. No, normally I will keep it down to 0.5 microliters, which will make it more better equivalent with the sperm freezing media with the cryoprotectant, and also it will have a better decreasing temperature speed. So, and for the thawing parts, if the volume of if each vial is low, it will be much easier and faster to have it thawed from solid to liquid. So that's my experience on that. If we get poor thaw motility, where have we go wrong? I think it really depends on how it goes. So you definitely we need to look up to the whole procedure, and still just pay attention the way you again the way you adding the freezing media. It is important to have it to add the media drop wisely and mix it thoroughly and gently, and leave some time, leave at least 5 to 10 minutes for sperm samples to equivalent with the freezing media. That is important, and that does have some effect to the outcome of the post-thaw. That is the main part, and you can to freeze each sample. You can allocate a very little portion of it for test. So next time when you want to thaw the sample, you can just thaw. You don't have to thaw the whole sample. You can just thaw that's very small portion for test to see whether it is good or not. And I used to hear a presentation from the director of the sperm bank from IVI group. So he mentioned even for the same donor, the multiple samples of the same donor, the sample outcome from the same donor is different. So it varies just the same as it varies for the parameter of each sperm sample. So just pay attention to the details, and it will help you with the outcome. How many seconds? Normally, we don't have that very detailed seconds between each job. It's just like to job wisely. And normally it will take like 5 to 10 minutes to adding all the media, which based on protocol like 1-to-1 ratio or of the sample and medias. Do you have experience or personal opinion regarding various devices used in cryopreservation of low quality samples? That's an interesting question. So yeah, I did try different, because like I was an embryologist in the lab in China, so we have a bunch of different devices here, which was domestically manufactured. So we have kind of I think for mostly used is the freezing vial, and also we did use the straw, the straw for sperm freezing while if the sample volume is really small, and I also tried the micro freezing for the oligospermids. Yeah. So if the sperm count is really low, so I think it's more or less the same. I think the most important part for sperm freezing is not really related to the device, and especially for low quality samples. I did ask the opinion of the lab director or from other labs, and we have some discussion on that part. So mostly they will tell you, especially like I think there's one lab here in China. They are really experienced with the with the sperm cryopreservation on low count samples, like from the Tessa or Mesa or oligospermia. So they are using the little drops, like 5 microliter drops, and capture the sperm, the motile sperm or vibrating sperm using ICSI needles, and put it into the 5 microliter drops, and then dip it into the liquid Viper, and then put the device into the freezing vial, and then storage. And so so mostly their opinion is that for those patients, it's more or less a backup. So that means the next time while they're having the egg retrieval, they need to do the next ICSI. So they always have the sperm to fertilize. They always will have their own sperm, and the only thing they can confirm is that the sperm, which is used to freeze pre-freeze, is alive. So that's the only thing they can guarantee. So they cannot. So it's more or less a backup. And if there is fresh samples for that, definitely fresh samples is the very first option. So yes, for low quality samples, I don't. So for my experience and from my talk with the other embryos, I haven't heard any other really good ways or methods to help with that. It will just for the backup and for the guarantee for patients that they don't have to go through multiple procedure, or they don't have to use the donor sperm. So any other questions, or if there's no other question, or if you do have any other questions, you can just email me. I have put my email address on the last slides, and you can just contact me anytime on any topics along the in this field, and I'm happy to help, and I'm happy to share all the information I can get, and you're so welcome to so welcome to ask anything if you like. And as Fujifilm Advanced Scientific, we will continuously to provide this kind of virtual launch on every single step of the technology, and we want to be your assistant and support with your work. And have a nice day. So we will see you in 2 weeks or for the next session. So thank you everybody for joining today's session. You can contact me through email, or you can contact me through you can send an email to me. You can leave message on our website for any additional information about the product, about the technique, about everything. Okay, thank you everyone to join to this session. Have a nice day.